Here is the sensor of our car, and if the sensor tested it's black, then the voltage here you can see that it's almost 4 volt, and if it tested here it's white, then the voltage will become really low and maybe just 0.2 or 0.3. So that's why we can tell it's black or white.
And here is the figure of the motor drive and the peak, the wire connections. Here is the peak, here is the motor drive. And we can get the input signals from the RB4 and the RB5 and RB6, which is the left sensors, middle sensors, and right sensors, which you can get logic values from it. And then we can use the code to decide the motors to which to drive, which is output is RC4 and RC3. And RC4 is connected to the 1A, and RC3 is connected to the 2A's, which is influence the 1Y and 2Y's to make the left side of motors to drive forward or stop or backward. And here is the flowchart of our project 1. First is get the signal from the sensors, and then signals put through to the microcontrollers, and then to make the motor drives to set signals to motor drive, then motor drive to get the motor's signals to make the motor to forward or backward. Then when after motor drives, and the robot will get the sensors back to here. So that's all. That's all.
Yeah.
Hi, this is our project 1, truth table. We have our right sensor, our middle sensor, and our left sensor. Now the most important thing in the truth table is you know what the binary code means. 0 stands for black, or when our sensor senses the table. White stands for the tape. Let's go through the different operations here. We have forward, right, left, back, and turn. Now there are 2 different modes of operation. One of them is trying to follow the line. It sort of goes around and tries not to step off the line. It senses where the tape is, and it continues to follow around the track. And that's going to be operation 1 we have here, follow the line. We have forward, right, left, and stop. Then there's operation 2. The same setup here, except now we're trying to avoid the black line. Our robot actually is going to stay inside of this circle, and when it senses the line, it's going to do what? Well, if all 3 sensors sense a 1, 1, 1, 1, on the second mode of operation, avoid the line, we're going to go back and turn. So as you can see, our robot here, as soon as it senses the line with all 3 sensors, it's going to go back and turn. So I'm going to draw the turn robot. There's a certain delay we actually put in the code to determine how far back it's going to go. Let's look at the other operations. Also avoiding the line, when we get 3 zeros or it senses the tabletop continuously, it stays going. That means that it hasn't sensed any of the white tape yet. If on the right we sense the tape, well, what are we going to do? We're going to avoid the tape by going to the left. If we sense the tape on both the middle and the right sensor, how are we going to react? We're going to go left even faster. To do this, we had one wheel turn reverse and the other wheel turn forward to give sort of a torque motion. It sped up the code and really helped our robot to avoid the line. We tried both ways and we found that this was much more successful than the conventional stop the wheel and move the other one forward. Similarly, on this side, if we sense the tape with the left sensor and the middle sensor, we turn right fast as well. You can see that. Now a little bit more mild turns can be seen when we sense it only with the right sensor or only with the left sensor. In this case, it simply turns right to avoid the tape on its left, or it turns left to avoid the tape on its right. Alright, let's continue. Now we're going to take a look at what happens in the follow the line mode. In the follow the line mode, if it doesn't know exactly where the line is, it's going to keep moving forward in hopes of finding the line. This case is represented by 0, 0, 0, 0. This is when it's maybe not exactly sure. The danger of the 0, 0, 0 situation is that it could actually fall off the table. So something that could be added maybe next year in the model would be a white line tape around our circle for robots that are trying to follow or avoid the line, so if they stepped over, which has happened to us, they wouldn't go off the tabletop, they would sense another white line and either A, follow it in case number 1, or B, avoid it. So Professor Natarajan, I would submit to you that it would be an awesome idea to put an extra layer of tape to preserve our hardware. Okay, now let's continue looking at the truth table. In the case where we're trying to follow the line, if you sense tape on the right, you'll try to follow that tape. If you sense tape on the left, you'd also try to follow that tape by turning left. Next, if we are trying to follow the line and we're successfully on the line, our sensors on the left, middle, and right would all sense a 1. We would simply keep right on going because we're doing great. Okay. But what if we did keep going, if we sense it on all 3 sensors? Let's go back to our case diagram here. Here's our robot. You can see that it senses the tape right here. If it kept going past this point, it would actually plummet off the table. Unless, of course, we had that white line around to make it rethink its actions. Okay, so if we do sense all 3 sensors with the 1 or the white tape, we'll stop. This is to prevent our robot from falling off the table. Now let's look at some of the other operations we have going on here. If both the left and the middle sensor sense the tape, we're going to continue going left. If both the right and the middle sensor sense the tape, we're going to continue going right. You can see the different dichotomies working its way out in this robot design, and it's really fantastic. We got to put the logic and the simple understanding of following the tape and avoiding the tape into 0s and 1s. Thank you so much. Looking forward to Project 2.
哎，赶紧拿了，我要断电了。
来开始。往这儿靠，往这儿靠，往这儿靠。开始。
随便碰它一下啊，碰一下。停啊！
开始。他没 follow the line， 怎么还转了一下？操！来，开始。
So 应该 should be
随便
clockwise.
随便，赶紧的。
注意它那线别断。